Hi, and welcome to this video on the question 3 of paper 1 from the Leaving Cert Ordinary Level Maths in 2020. So as always, if you want to copy these notes, just get through to me on shanetroy@gmail.com and I'll send them off to you. And let's get stuck in. I haven't actually prepped this question in advance, which is always a dangerous place to be in. And question 3 is this year, anyway, is complex numbers. So I personally like complex numbers, so happy days. So complex numbers again are just every number is a complex number. There's a whole pile of theory behind this. But from a practical perspective, answering the question, there's only a few things they're likely to ask. Some will be the operations. So can you add, subtract, multiply, and divide complex numbers? Can you graph them on the Argand diagram? Can you find the modulus, which is the distance from the complex number to the origin? And really, for most practical purposes, that's going to get you in good stead. Okay. One of the really important features is this concept that I squared equals minus 1, which relates to the other concept that I is equal to the square root of minus 1, which is those two concepts are core in complex numbers. In this first one, so Z1 has a real part and an imaginary part. And it's worth saying like every number is complex. Okay, they have a real part and an imaginary part. Just for most numbers we're familiar with, the imaginary part is 0. Okay, but you can express them as a complex number. That's probably a bit more advanced than you need for ordinary level, but again, sometimes that's handy to get a handle on this. So anyway, they tell us that the complex number there, Z1 is 3 take away 4i, or 3 minus 4i, and the second complex number, Z2, is minus 2 plus I. Now they tell us that the third complex number is Z3, but they give it to us in code. Okay, so they're saying that Z3 is equal to twice times I times Z2. So twice times I times Z2. Now, we don't need to worry about what I is, okay, but with Z2 we were given that, okay, that's that. So this is 2 times I times minus 2 plus I. Now it might be smart to put that in brackets just to remind yourself that you're going to be multiplying by both of these terms. Now that's the equivalent to 2i brackets minus 2 plus I, which might be more familiar to you, okay. Now this part A, 1 and 2, if I recall from the marking scheme, are worth 10 marks. The third part is worth 5 marks. So look right there, you at least have the low partial 3. Okay, you've done like a correct, well, you have to do the operation, but you've set up a correct relevant step. So if I've set it up and go, look, there's brackets, I don't know what to do, remove them. So plus by minus is minus, 2i by 2 is 4i. Now multiply the 2i by I, so 2i by I is 2i squared, just as if it was x by x, okay, is x squared. Now here's where this concept of I squared equals minus 1 comes in. This is equivalent to minus 4i plus 2 times, now if I squared is minus 1, can't I swap them? Now I've gone a bit messy here, but minus 4i, so plus by minus is minus, 2 by 1 is 2. So again, I just see brackets, get rid of them. Okay, if you're not sure what you're doing, that's as good a strategy as I can think of. Now, that's what Z3 is. So a bit long-winded on the maths part of it, but that's all you're being asked to do. Now, part 2 here says plot Z1, Z2, and Z3 on this diagram. They give it to you as pre-labeled, so happy days. Now, Z1, there's 3 on the real axis, minus 4i on the imaginary. So this is the line where the real part is 3, and it's minus 4i crisscrosses this part here. Now, when I do this, I always kind of, if I'm labeling it, I write the I. I don't need to do it here. I'm just doing it to represent that, okay? You don't have to, because every number on that is imaginary. That's what this thing is saying. But this is kind of how I learned how to do this. This is kind of how I do it in my head, even if that's all. So the first one's 3 minus 4i. That's roughly there. Okay, now you're asked to label it. Okay, you could use the Z1. Okay, you could use both of them. Okay, but if you don't, they do directly say label, so there can be a penalty for that. Now Z2 is minus 2, so over here, somewhere along this line here, where does it cross with plus 1i? It crosses here. And that's minus 2 plus I. Again, I'm going to overkill it. I'm going to put both. And the last one, now Z3. Now, whatever you declared here, if you represent it properly on the Argand diagram, you're going to get the marks. And the reason I'm saying that is that's a really useful thing. Okay, so this is -2 on this -4a, so it's down here. Now let's say I had done that incorrectly. Okay, whatever answer I got here, whatever I then write here will be accepted as correct. Okay, so if I didn't know, pick something real simple. Okay, if I said 1 plus 1i, okay, whatever there, even though it's wrong here and there's a penalty applied, it's accepted as fully correct here. Now that's a really important thing to remember all across the maths paper. And there are situations when it might happen to you, you just can't do the first part, but you know how to do the second part. Well, all you have to do is simply declare an answer for part one, use that as correct in part two, happy days. Okay. Now, obviously, if you know how to do both parts, that's better. But look, things happen. Right. That's that. Okay. So that's part two done. Now, this next bit is the modulus of. Now, those bars in effect mean distance, but in maths, that would be called the modulus. Now, the modulus formula is basically a rearrangement, in a sense, of Pythagoras. Okay, and they're looking to find Z1. So, what's this length here? I hope I draw this right. Okay. Now, in reality, if you think, okay, if I create a line here just to illustrate it, hope that's visible on your screen. Okay. What shape have I created? Well, I've created a right angle triangle. This has a side of 3 units. This is a side of 4 units. Okay, so this is a right angle triangle. This is Pythagoras. If that's my hypotenuse, okay, or my longest side, the hypotenuse squared is equal to the sum of the squares of the other two sides. I'm calling A and B. Now, if I rearrange that, just bring the square across, the square roots everything on the far side. Isn't that the modulus formula? Okay, now that's where it comes from. I'm going to go to the next page because I have this all done out prettily. Okay, so I'm putting in there, instead of the Z1, I'm putting in the 3 minus 4i. Again, that's what I was given. Now I'm putting on top here, that's just a plus bi, just so you know, the a is the 3, the b is the number in front of the I, which is the -4. This is my modulus formula. Instead of a, I'm putting 3. Instead of b, I'm putting -4. Put to the calculator if you want. As long as you make sure the -4 is in brackets, it won't return an error. And that's 3 squared is 9. Okay. -4 squared is -4 times -4, which is plus 16. That's there. Then just simplify by adding the two numbers. 9 and 16 is 25. And the square root of 25 is 5. And that's it. Okay. So happy days. So again, that's 15 marks for part A and A1, 2, and 3. Okay. Now part B here is worth 10. So let's see if we can just grab the 4. That is, this is a 10C scale. So that year, 4 marks got you the low partial. It's saying if Z1 times Z4 equals 29 plus 3i, write Z4 in the form blah, 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 blah. Okay, don't worry about the rest of this for now. That's just telling us how to write our answer. So look, I can BS this to a certain extent. And if I go back one page, that's the answer. Z1 is 3 minus 4i. So that's saying if I multiply 3 minus 4i, okay, by Z4, okay, that equals 29 plus 3i. Now, by substituting that in, I'm most likely, I can't remember exactly from the scheme, but I can't see why you wouldn't get the low partial. And then you can start off from there. You go, look, I want Z4 on its own. I want to know what Z4 is. So let's move everything to the far side. So if I do that, okay, this 3 minus 4i is being multiplied by Z4. When it moves over to the far side, it does the opposite. And it divides into everything on the far side. Now, once I'm here, now if you know your complex numbers, this is division of complex numbers. So if you recall at the beginning of this video, I said they're going to ask you to look at addition, subtraction, multiplication, and division, okay, the Argand diagram and the modulus. So this is division. Now to divide a complex number, you have to multiply, okay, which is great. I don't like division for some reason in my head, okay. Multiply top and bottom, okay, by the, now this is the weird thing, a thing called the conjugate of the bottom. Okay. Now what's all that saying? So you multiply top and bottom by what's the conjugate of the bottom. Now, if I go back to the thing here, this is your 3 minus 4i. Okay, there. We found the modulus of that area was 5. Okay. Now, the conjugate is the equivalent complex number directly above. So that's the conjugate of Z1, and they denote that with a bar on top. So the way to find that, okay, simply is if this is 3 minus 4i, well, what's this? 3 plus 4i. So the simplest thing is just we learn off, I suppose, is to find the conjugate of any complex number, just change the sign in front of the I. Okay, happy days. So what's the conjugate of 3 minus 4i? It's 3 plus 4i. So I'm multiplying top by 3 plus 4i and bottom by 3 plus 4i. Now that's a whole pile of calculations. So look, if I want, I can use a rough work. I can go over to an area, okay, and go, well, look, 29 plus 3i, you're multiplying that. Now, I prefer to use brackets for multiply by 3 plus 4i. Now, I'll do one of them, okay? You can do it kind of faster by tracking things. But a good standard way of doing it, especially in an exam when you don't want to make an error, is I would say write one of the brackets out twice. Now, I always write out the second one because that's, again, how I learned it, okay? And I multiply the first term into the first bracket and the second term into the second bracket. And then if I go left to right now and just remove brackets by multiplication, I'll hopefully not make an error, okay? Now, 29 by 3 is an error I'm going to make. So I should use my calculator. 3 9s is 27, 2 2s is 6, 8. Okay, so 87. Now, 29 by 4i, okay, is 29. 16, 8, 9, 16. Again, I should use my calculator. I'm notorious for making little errors like that. Now the next, so I've done that bracket. So 3i by 3 is just tripling it. So 3 apples by 3 is 9 apples. 3i by 3 is 9i. And then 3i by 4i, so it's all pluses. 3 by 4 is 12. I by I is I squared. Now this is where this I squared is equal to minus 1 thing comes in. This is going to be swapped out. But the middle thing here can be added. So if I do that, because 87, 116 plus 9 is 125i. Plus 12 times, and we said I squared is minus 1, so I can swap them. Now I've created a problem though. This is a bracket, needs to be resolved. So all I'm doing right here is doing that. Plus by minus is minus, 12 by I is 12, 12 by 1 is 12. So plus by minus is minus, 12 by 1 is 12. Now I can subtract them. Okay, so 87 take away 12 is 75 plus 125i. Okay, looking nice. Now I'm going to try do the same thing. Okay, if I don't know why it does that. I'm not trying to change the page. Okay, next one is 3 minus 4i, okay, by 3 plus 4i. Now, when you multiply a complex number by its conjugate, the i's are going to disappear. I'm going to do this the fast way, though. Okay, even though I suggested you shouldn't, I hope I don't make an error. But 3 by 3 is 9. Now, 3 by 4i is 12i. Now, on the top, minus 4i by 3 is minus 12i. Minus 4 by 4i, minus by plus is minus, 4 by 4 is 16, I by I is I squared. But two things, remember we said I squared is equal to minus 1, same thing going to happen here. And you go 9, now plus by minus is cancelled. They've literally cancelled each other. Now the minus 16, you're replacing the minus 1 by I squared, and that becomes what, 9 minus by minus is plus, 16 by 1 is 16, 9 and 16 is 25. So a nice handy number. Now I might as well go to the nice pretty page on the next one, okay? So that was my top bit done. That was my bottom bit. Now here's where the last thing comes into play. It says leave your answer in the form of A plus BI, not A plus BI over C. So whatever's down here, all you have to do, and it should be fairly obvious, 25 into 75 goes 3 times, 25 into 125 goes 5 times. Okay, so you're just basically dividing each thing by 25. and you get the simpler answer. They are the equivalent of each other. You just have to go the final step, and that's just to get the final marks. Okay. So look, it's a fairly bog standard question. So let's just reflect on what we did. Okay. Um, I have my statement I was given in the question. I knew what Z1 was. I was told that in part A. So I swapped them out. And then I look and go, what can I do here? Can I do anything? Well, look, I have one unknown, so let's bring everything across. Now, I is not unknown. And then I have this statement. Now, if you stop there and you get the low partial 4, look, happy days. Okay. But if you know what the next step is, that's this rule. You're not given it, you have to kind of memorize it. Then if you identify the conjugate, which we did, and you multiply top and bottom by the conjugate of the bottom, and then you have to do all this work. Okay. Eventually you get to your answer, and we just have to leave it in the form they want it, which is kind of how you do it anyway. So I said here, don't worry about this last bit. You don't really need to, okay, until the end. But so you can't get to the end, well then there really is no worry about that. Okay. So we're basically done on question 3. Okay, so this again was Maths, Ordinary Level 2020, Paper 1, question 3. If you want to copy these notes, just email me at shanetroy@gmail.com and click subscribe. You'll be able to see easier access to all the different playlists from Leaving Certs from over the last few years. Okay, thanks very much.